Okay, 11.2, I need to recalibrate this. Okay, 11.2 is vectors in a plane. Okay, so 11.1 was about parametric functions. Now we're going to learn about vectors in a plane. The last section, 11.3, is polar equations. So 2 years ago in trigonometry, you learned about vectors, a whole chapter, chapter 8. Basically, this is what I'm going to do right now. It's going to take me a while to teach these notes. The first thing I'm going to do is give you a quick little notes on everything about vectors from chapter 8 in trigonometry. And then after that, after I review everything with you, I'm going to teach you how to find, for calculus, how to find the derivative integration of vectors. Same thing with 11.3 when you get to 11.3. The first thing I'm going to do is reteach you polar equations, and then I'm going to teach you the calculus version of polar equations. So this will take a while because I'm going to teach you vectors that you learn in trigonometry. So vector has magnitude and direction. So basically, this is vector A. In trigonometry, we skipped the first section, 8.1. They wanted you to figure out the magnitude and the direction by using a ruler and a protractor. So they wanted you to measure this vector A. They wanted to figure out what the how long it is, or the distance of vector A using a ruler in centimeters. But we skipped that section, and then the direction is the angle that it makes, and it looks like about 45 degrees. Without a ruler, without a protractor, there's a formula to figure out the magnitude and the direction. So let's just start with magnitude first. Like I said, all of this stuff is not calculus. All of this stuff that I'm teaching you right now is just what you learned in trigonometry 2 years ago. The magnitude is the length of the vector. And this is a really important formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And if you remember, this is the distance formula that you would have learned in geometry. To name a vector, or no, direction, I'll explain the direction in a little bit. But to name a vector, you name the vector, it's called the component. And we're going to talk about components. And basically the formula is x2 minus x1, y2 minus y1. This is also called, again, vectors deal with motion, like airplanes and boats. So you would use this in story problems like planes and trains and automobiles and everything else. So let's do a component form of a vector. Let's do some examples. I'm going to give you these vectors. Vector A is 0, 0. Vector B is 3, 4. Vector C is a negative 4, 2. And vector D is negative 1 and 6. They want you to show you that U the distance from A to B is equal to the distance from C to D, the distance. So we're going to do the distance between A and B and the distance from C and D are equal. So I'm just going to use the distance formula. The distance from A to B, we're going to say that that's the letter U, and the distance between C and D is the letter D. When they put a line, absolute value, it means distance from now on. It means length. So when you see these two bars, it means distance. So all you're going to do is take the square root, and you're going to take x2 minus x1. So the x2 is this one, and the x1 is this one. So 3 take away 0 is 3, and you square it. 4 take away 0 is 4, and you square it. And you get 9 plus 16, which is the square root of 25, which equals 5. I'm going to do the same thing with the distance of vector v. This is x2, this is the first x1, this is y2, this is y1. x2, I'm going to show my work on this one, a negative 1 minus a negative 4 squared plus 6 minus 2 squared equals 5 squared. A negative 1 minus a negative 4 is 3, and 3 squared is 9. 6 take away 2 is 4, 4 squared is 16. You get also 5. Okay, so in this book, they're going to ask you, for example, to find the component for and length of vector. And they give you 2 points. P is equal to a negative 3 comma 4. This is the initial point. And the terminal or ending point of your vector is a negative 5 comma 2. This is important. Initial and terminal. Initial starts it, terminal ends it. So this would be called the initial point. It starts it. Somewhere right here is the terminal point, which ends it. It's important because then you know that this is x1, y1, this is x2, y2. So the first thing I'm going to do is find the component. To find the component, I'm just going to do x2, which is a negative 5, minus a negative 3, and I'm going to take 2 minus 4. So what's the component? The component is a negative 2, negative 2. Then they're going to ask you to find the length of the vector, which is the square root. Basically, if you look at the formula, if you take x2 minus x1, okay, so if they give you this, this is something, oh, I have to finish this, sorry. I was talking about this and then somebody came in to my room, interrupted me. So, do you see the name of the vector is right here, which is called the component, and this is the length of the vector? Do you notice that x2 minus x1 and y2 minus y1 is inside of there, and all I have to do is square it? So, this will save some time. Well, this is x2 minus x1, this is y2 minus y1. All I have to do is square both of these, which is the square root of 8, which ends up being 2 square root of 2, which is the distance. This is the distance, or the length of the vector. This is the component of the vector. Okay, here's another way to find the component. Find the component vector given the length of 3, and it makes an angle of 40 degrees. It gives you the length and it gives you the angle. You kind of know what the vector kind of looks like, right? I don't know if it's 3 inches or, but 40 degrees looks like this. It's about 40 degrees, and that looks about whatever, 3 centimeters or 3, whatever they're talking about. So, if they want you to find the component vector, here's another way. The component vector is, I'm just going to show you right here. The component vector is equal to 3 times the cosine of 40 degrees and 3 times the sine of 40 degrees. I don't know if you remember this, but in trigonometry, the formula to find the x value is r cosine of theta, and to find the y value, it was y sine of theta. And you're going to get more of this in the next section, but that's the formula. When you put this into your calculator, 3 times the cosine of 40, you're going to get 2.298, go always out to 3 decimal places, and 1.928. So, another way to find the component is using this formula. So basically, before we go on to the next part, I'm just going to recap what we've learned so far. So far, we learned how to find the length of a vector, which is right here. It's called the magnitude. And we also learned how to name a vector, which is right here. The last thing we learned is another formula to find the component of a vector, and it's right here. Okay, the next part, before I better write this down, it's in the notes. What does a zero vector look like? Well, it's not that hard to figure out. A zero vector has 0 length and has 0 direction. Just to let you know that a zero vector has 0 length and 0 direction. Okay, I'm going to go over some more properties. And these are some operations of vectors. So what am I doing right now? I'm not teaching you calculus. Basically, I'm trying to get in a full chapter of what you learned in trigonometry. So this is just a quick review. Vector u is equal to, okay, the book uses this as a vector. They use like this. And vector v is 4, 7. I don't care if you use these or if you use parentheses. To me, it means it's the same. If you see this on the AP test, it just means a vector. If you see this, I don't care which way you want to write it. So just keep that in mind. Sometimes I'll use parentheses. Sometimes I use the little angle, like the little sharp corners. So let's say you want to add the operation of vectors. Maybe you want to add the 2 vectors together. I remember you guys did this, and all you're going to do, final answer, I'm just going to use these instead. You're just going to add them together. What's a negative 1 plus 4? 3. What's 3 plus 7? 10. That's how you add 2 vectors together. How do you subtract 2 vectors? Same thing. U minus v, a negative 1 minus 4 is a negative 5. 3 take away 7, negative 4. Let's say we want to do, this is called scalar multiplication. Let's say we want to do 1/2 of u. Let's say we want to do 1/2 of u. So all you do is you take 1/2 of a negative 1, which is a negative 1/2. 1/2 of 3 is 3/2. What is this called? If you really care, it's called scalar multiplication. So you learn how to add, subtract, and do scalar multiplication. For example, let's say they wanted you to find, the absolute value of 1/2 u. Okay, remember, this isn't really absolute value. Well, it kind of does. What this is the length. Remember, the 2 bars stand for length. So I'm just going to take the square root, and I already took 1/2 of both of them, and all I'm going to do is square both of these that I just did. So what's 1/2? Negative 1/2 times a negative 1/2 is 1/4. Plus 3/2 times 3/2 is 9/4, which is the square root of 10 over 4, which makes the square root of 10 over the square root of 4. Remember, you can always split up your radical into the top and the bottom. which gives you the square root of 10 over 2. Final answer. So just quickly, the operations of vectors, I just kind of went over them. There's some more properties on page 547. Let's see. It looks like I went through most of these. 547. You can look over some of the properties on page 547 if you want to. I'm just going to look over them just really quickly to see what they look like. They're all the properties that you would have learned: adding, subtracting, multiplying, dividing. So just look over your properties. A couple more things. How do you find an angle between two vectors? For example, let's say this is vector A, and let's say this is vector B. And you're trying to find the angle between these two vectors. Again, you learn this in trigonometry, but this is how you find the angle, or theta, between these two. It's the cosine inverse of u1 times b1 plus u2 times b2 all over it's the distance between them, or the length of u and b. So, I was going to give you an example. Well, I mean, whatever the vector, you just take u1 times b1 plus u2 times b2, trying to see if I can find an example here if I did one. I don't know if this is going to come out. I'm just going to pause this and look to see if I can find an example for you. Okay, I didn't, but I'm just going to try to make one up. Vector u is like 0, 4, and vector v is 1, 8. And if you want to find the angle between this, I don't know if this is going to work, but I'm just going to, you need to find the length of u. You can find the length of u, and you can find the length of v. You can find the length of v using the distance formula. And then what do you do up here? You take u1 and multiply it by b1. So basically you're going to take the first term in 0 and multiply it by 1, which is 1, plus 4 times 8 is 32. So basically you get 33 on the top. And then you need to divide by, I forgot to do the cosine inverse, sorry. I don't know if this is going to work, but you get the idea about the uv and the u2, v2. And then what you do is you find the distance. And the distance of u, remember, is 0 squared plus 4 squared. And the distance of that is 1 squared plus 8 squared. And then you take the square root of that, and that'll give you the distance. And the distance, you multiply them together. You take 33 and you divide them by this number, and then you use your inverse cosine button on your calculator. I don't know if this is going to work. So the distance of u is the square root of 0 squared plus 4 squared, which is 4. The distance of this is the square root of 1 squared plus 8 squared, which is the square root of 65. So, on your calculator, you're going to take 33 and divide it by 4 squared of 65. And then you're going to do the inverse cosine, and I don't know if this is even going to work, because I just made the problem up, but I'm just going to see what happens. Inverse cosine of 33 divided by 4 times the square root of 65. Like I said, I don't have a clue if this is going to work. No, it did not work. But anyway, that's what happens when you make up your own. You get the idea, though, on how you find the angle in between two vectors. Again, you multiply u1, v1 plus u2, v2 divided by their lengths multiplied together. Okay, the next thing I'm going to show you is finally how to model planar motion. And then I'm going to get into the calculus part. So this still is from 2 years ago. A plane is going due east at 500 miles per hour. He encounters a wind 70 mile per hour tailwind in the direction of 60 degrees northeast. What they want you to do is they want you to find the new plane's direction and magnitude. So, if you think about it, I'm going to start at the vector u. Vector u is starting at 500, 0. The vector v, I need to end at what the ending vector is, and the ending vector is 70 times the cosine of 60, and 70 times the sine of 60. This will give us our ending. So I'm going to try to draw you a picture. So you can laugh all you want, but that's a plane. And this is the first vector. The first vector, u, is at 500, 0. And then what happens is there's a wind, and that wind is going 70, and it's going to move the plane 60 degrees. Basically, we need to come up with the new direction of the airplane. I'm going to call it W. And I want to know how much that plane has changed, which is theta. So basically, I'm going to find the angle and the new direction of the plane. So, how do we do this? So, the first thing I'm going to do is I'm going to find u plus v. Or, this is the distance of our new plane. So it's the square root. But before I do that, I need to figure out what 70 cosine of 60 is and 70 sine of 60 is, which I'll give you right here. This is my other vector. You're going to get 535 for the first one, and you're going to get 35 square root of 3 for the next one. Okay, you need that. Because to find the distance of u plus v, is basically the distance of where it's changed already. So we're just going to take these two and we're going to square them. We're really just finding the vector v, which is the new one. 535 squared plus 35 square root of 3 squared. And you're going to get 538.4 miles per hour. So basically, the plane used to be going 500 miles per hour, and now it's going 538.4 miles per hour. And the angle that it makes is tangent inverse of y divided by x, which is tangent inverse of 3 square root of 5. I did that wrong. 35 square root of 3 divided by 535. And you're going to get an angle of 6.5. So the airplane moved in the air degree 6.5, and it's going up. It's going up to 538.4. Okay, Now I'm going to start teaching you the calculus. Using calculus. A particle position is x sub t, y sub t. The particle's velocity is just the derivative of that, dx dt, dy dt. It's not too difficult. The particle's acceleration, or no, let's do the particle speed first, is the absolute value of v. But remember, absolute value is the distance formula you're going to be using. The acceleration is just the double derivative, d squared x over dt squared, and d squared y over dt squared. The direction of your vector is v divided by the distance of v. So, I'm just going to give you an example. Calculus now. They give you the position of the vector. Vector v, let's call it. And it's sine of t, and it's t squared over 2. So far so good. That's the position. They want you to find the velocity, and they want you to find the acceleration. It's not hard at all. All you're going to do is you're going to find the derivative of each one of these. What's the derivative of sine? Cosine. What's the derivative of t squared 2? You bring the 2 down, and that's what happens. The 2's go away, and then you go down by 1. So that's the velocity. The acceleration, what's the derivative of cosine? Negative sine. What's the derivative of t? 1. So finding the velocity and acceleration of a vector is not that difficult. For example, one more. If they're talking about a plane, and they give the position of the plane, and they call it RT, or whatever they want to call it, as sine of 3t, cosine of 5t. And they want you to find the velocity and the acceleration. So, velocity is equal to, okay, but all we're going to do is find the derivative of both of these, and that's pretty much you're done. But you notice you have to use the same rule to do it. The derivative of sine is cosine. Leave the inside alone, and then take the derivative of 3t, which is 3. The derivative of cosine is negative 5 sine of 5t. I'm going to pause this for a few seconds again. Okay, so I'm running out of time. I gotta go do ISS right now. So basically I'm just going to end these notes here. And I will finish this on a second part of 11.2. Sorry, I forgot I had ISS today, so I've got to go up there. So look over 11.2 second part when I get done. So.